Okay, today we're going to look at equations and why we do what we do in order to solve them. I know you see a lot of times we have equations, you have an equation that you have to solve, and you're wondering what steps do I have to take and why do I have to take those steps? So we're going to look a little deeper into why we actually manipulate equations the way we do. Okay, first let's look at a definition for an equation. What is an equation? An equation is a term or expression that is equal to another term or expression. Okay, so let's look at a simple equation. Okay, x plus 4 equals 7. And that's really simple. You probably don't really have to do the math to even figure out what the answer is. We can see that x has to be equal to 3. But we teach you on simpler equations so that when the equations get more complex, you can apply those same principles. Okay, so as you can see here, look at the balance as being the equal sign here. So this is like the equal sign. Okay, and as long as it is balanced, then it is equal. So, and this is more like a visual image of what this equation is saying, what that mathematical sentence is saying. Okay, so before we actually get started looking at another equation, let's look at what the definition of algebra is, because I think it may lead to a little understanding. Okay, so algebra is mathematics in which letters and other general symbols are used to represent numbers and quantities in formula and in equations, which means that x, when we write an x in algebra, it has a value. It has a numerical value. So when we look at why we do what we do in algebra, it's because we're trying to figure out what that numerical value of that letter is. Okay? So we are trying to isolate that variable, because if we get it by itself, then that's how we figure out what the value of it is. Okay, so let's look at this equation. Okay, we have 6x plus 14 is equal to 2x minus 2. And here, this is the mathematical sentence, and here is the graphical representation of that mathematical sentence. 6x plus 14 is equal to 2x minus 2. Okay, so we understand that part. Okay. So let's look at the 14. We know what the value of 14 is, right? You understand what 14 is. We have a visual representation of what the number 14 is and what it's doing. It's being added to whatever this value of 6x is. Let's look at the 6. We understand the concept of what the 6 is, and we see that it is 6 multiplied by whatever this value of x is. Okay, and when we look at the 2's, now there are two different 2's here. One 2 is being multiplied by x here, and the other 2 is being subtracted from whatever this value of x is. So we still have a concept of what that value of 2 is. We know that 2, if you multiply 2 times something, you're doubling it. If we know that if you subtract 2 from something, then you're taking 2 away from it. We have a mental concept of what 2 is, right? But what we don't have a numerical concept is is what is x. Now I'm sure that there are some students who could manipulate, and if they sat and stared at that problem long enough, they could figure out what x is. But if we, like I said, if we teach you the steps in simpler problems, even though this is not the simplest problem, then you can learn, you can use those same steps when the problems get too complex that you can't just look at it and figure it out. Okay, so let's focus on this equation again. Okay, so let's look at this equation again. Now, what can we do to this equation to keep it balanced, but we can manipulate a little bit? Now, I like to point this out to students because you'll see this happen on problems when you see examples where someone else has worked it, and they'll switch sides. And a lot of students are like, well, what happened? Why is that on that side and why is it on the other side? So if I move this x plus x 2x minus 2 this side, and I move the 6x minus 14, plus 14, I'm sorry, to the other side, then it does not change the balance of the equation. They're both still equal. It's fine. That's fine to do. And so when sometimes you'll want to do that, because if the x's are maybe on the left, on the right instead of the left, and if you're like me, I like to solve equations where my x's are always on the left, then I will just switch them around like I did here in this example. So it's okay to do that. That still keeps it balanced. Okay. And just looking at that equation that we had earlier, x plus 4 equals 7. It is the same value as if it was 7 equals x plus 4. So you can see how it's interchangeable. And I wanted to use that simpler equation because it's easier for you to see that 7 is equal to 3 plus 4, and 3 plus 4 is equal to 7. Okay? Okay, so let's look at this equation again, the one we've been using. Okay, so remember, we want to get the x by itself. Now, what we could do, we see we have a 14 over here, and we have a negative 2 over here. So we can maybe add the 14 to the negative 2. Or combine them, I should say, not add. So we just move it over, and we have 6x equals 2x minus 2 plus 14. So why? Okay, so that seems easy enough, right? But if we do that, then the equation becomes unbalanced. What we've done essentially is we've taken the 14 and we've moved it over to this side of the balance. So that tips the scale. So that's why we can't do that, because it causes the equation to become unbalanced. It's no longer equal. So it's no longer balanced, no longer equal, no longer true. Okay, so let's look at it again. Let's try something else. What if we just try to move the 2x over and add it to the 6x? So it'll be 6x plus 2x plus 14 equals negative 2. We'll have the same scenario. We basically have taken the 2x that was over here, and we moved it over here, which that's nice, but we've now made the equation unbalanced. You can see how it actually can perceive taking weight away, whatever 2x value is, away from one side and putting it on the other side of the balance. You can imagine that tipping a balance toward the left. And that's why we can't do it in algebra. It's Even it would be nice if we could do it that way. It'd make the problem simpler, but it's going to change the value of the problem. So again, if we do that, we no longer balanced, no longer equal, no longer true. Okay, so if we can't do that, then what can we do? That's the big question. What can we do? How can we manipulate the equation without making the equation unbalanced? Well, we have rules. Here are our rules. Okay. Our rules are, first of all, our first rule is we make zeros. So by making zeros with adding and subtraction of like terms. So anywhere we can add or subtract something together, if it's across the equal sign, what we do is we make zeros. And you'll see in the example a better illustration of it. And when it comes to multiplication and division, we make ones, because if you make zeros in multiplication and division, it goes away. So we don't want to do that. So we make ones. And the other rule, which is critical, is whatever you do to one side, you have to do to the other side. Critical. Because that's what keeps an equation balanced. So what we're doing in essence in algebra is we are manipulating an equation to our desire. But we always have to remember to do what we did on one side of the equation, we have to do it on the other side of the equation. We can decide to do whatever we want to one side, but we have to do it to the other side. So one is by choice, the other is by force. Okay, so I'm keeping the rules up here, the same rules. Okay, so, and here's the equation balance. Now, true enough, let's just say if I wanted to add 12 to this side. As long as I add 12 to this side, the equation is still balanced. But what would be the point of doing that? So we want to work smart, not hard, right? So let's get rid of that. Okay, so now, remember when it comes to adding and subtraction, multiplication, division, we're going to either make zeros with adding and subtraction or ones with multiplication, division. Another thing that you want to do in algebra is you work with your adding and subtraction first, okay? So a lot of time we like to do multiplication, division first, but no, it won't work. Believe me, it's much simpler if you do it that way. Okay, so we have 6x plus 14 equals 2x minus 2. Now, I can make a zero here on this side by subtracting 14, because 14, positive 14 and negative 14, that's their additive inverses, that's going to make a zero. Now, I did that on purpose because I knew it was going to make a zero. So this is the one I made by choice. Now, by force, I had to combine a negative 14 on the right side of the equation. That keeps it balanced, because you notice here, if you have minus 14 here, then you have minus 14 here. So what you did the same thing on both sides, so it stays balanced. Then oddly enough, a lot of times students have been taught, in order to solve an equation, you just take the opposite sign, where it was positive over here, switch it to a negative, so switch signs, and put it on the other side of the equation. And that is essentially what it looks like happens. But you can solve problems that way, but you don't get the concept as to why you're doing what you're doing. So yes, once you solve that way, the 14 was positive on the left of the equal sign, is now negative on the right of the equal sign. And you can now combine it, the negative 2 and the negative 14, and get negative 16. Okay, so now we're looking at let's look at the x's. We can subtract, and I'm picking this side of the equation 2x to get rid of that 2x by making a negative 2x because I prefer my x's to end up being on the left. It reads better. That's my choice. So by choice, I chose to turn this into a 0. So its additive inverse is negative 2x. But by force, I had to combine a negative 2x on the left side of the equation. So in essence, you see negative 2x here. I'm sorry. Yes, that's right. Negative 2x. I have to be careful about my signs. And that's something, no matter how good you are in math, you always have to watch those signs. And sometimes I think when you're really good at it, you're a little careless. At least maybe that's just me. Okay, so I'm doing negative 2x on both sides. And yes, so I did the same thing to one side as I did to the other side. So I have not taken my equation out of balance. Okay, so even though the 2x, so I made that 0 here on this side, and I combine, now I'm going to combine this 6x and the negative 2x. And when we solve, we get 4x is equal to negative 16. I kind of wrote in that spot, but you can still see it. Okay, so we got 4x equals negative 16. Okay. Okay, so now we're at 4x equals negative 16. Now we've gotten all the adding and subtracting we can do. So now we're looking at the multiplication and division. And here we have, now remember, we're trying to isolate the variable. So where I want to isolate is right here. I want to get rid of that 4 that's next to that x, because when that x is by itself, then I will have isolated it. Okay, that's what isolate means, to get something by itself. So if I take 4 times x and add the 4 times x and divide it by 4, I'm going to create some 1s, because 4, any number over itself is equal to 1, right? So, and remember, we don't write the 1 that's next to the x, but we understand that it's there. So I divide it by 4 by choice, but by force, I have to divide the negative 16 by 4, right? Okay. And you get negative 16 divided by 4 is negative 4. Okay. I wrote that in there too. Okay. So I have now figured out, now x is isolated. I know what the value of x is. It's negative 4. And I was able to manipulate the equation in a way by not taking it out of balance. That's the big thing. Now, I know you're taught just divide both sides by whatever is next to x, and that is true. But I'm just explaining to you why. Okay, so now that we actually know the value of x, we know that it's negative 4, we no longer have to use x as a placeholder. We can actually put the actual number negative 4 wherever the x is. So here you see 6 times negative 4 plus 14 is equal to 2 times negative 4 minus 2. So multiply 6 and negative 4 together to get negative 24 plus 14. And you multiply 2 times negative 4 to get negative 8 minus 2. You combine the left side terms, negative 24 plus 14 is negative 10, and you combine the right side of the equal sign, negative 8 and negative 2 is negative 10. With the reflexive property, we know that negative 10 is equal to negative 10. So the equation is true. Here are the basic concepts. I know that this will help you. Thank you.